What if your soul isn't a metaphor, but a quantum phenomenon? It sounds like science fiction, or maybe ancient mysticism. But today, we're diving into one of the boldest and most controversial ideas at the intersection of science and spirituality, the quantum soul hypothesis. The possibility that consciousness, and perhaps even what we call the soul, arises from quantum processes within the brain. Let's start with the basics. For centuries, science and spirituality have stood on opposite ends of the conversation about consciousness. Neuroscience says the mind is what the brain does. Electrochemical activity between neurons gives rise to thoughts, emotions, and awareness. In this view, when the brain stops, so does the self. But there's a problem. No one has actually figured out consciousness emerges. This is famously known as the hard problem of consciousness, a term coined by philosopher David Chalmers. While we can trace brain activity that correlates with emotions or decisions, we can't explain why subjective experience, the feeling of being you, exists at all. Why doesn't all this processing happen in the dark without anyone home? Enter quantum physics. In the 1990s, theoretical physicist Sir Roger Penrose and anesthesiologist Dr. Stuart Hameroff proposed a theory known as Orch OR, short for Orchestrated Objective Reduction. The core idea that consciousness is not purely computational like a computer, but rooted in quantum processes occurring inside structures called microtubules found within neurons. Microtubules are tiny tubular structures that help cells maintain their shape and transport molecules. But Penrose and Hameroff believe they may also support quantum coherence, the same kind of phenomenon used in quantum computing, where particles exist in multiple states at once. In their view, the brain doesn't just crunch numbers. It may operate like a quantum orchestra, where waves of possibilities collapse into experience. Consciousness, then, is not the result of classical logic, but of quantum decision-making. And here's the kicker: this might explain how consciousness could persist, even briefly, after death. During clinical death, when the brain stops functioning, some patients report near-death experiences, sensations of leaving the body, traveling through tunnels, meeting deceased relatives or spiritual beings. Mainstream science explains this as the dying brain firing off random activity. But Hameroff has proposed that if microtubules can hold quantum states, some form of consciousness might continue temporarily, even when the brain is clinically offline. But let's zoom out. To truly grasp the significance of this idea, we need to look at how quantum mechanics has already begun to upend biology. In the field of quantum biology, we've discovered that living systems may exploit quantum effects that were once thought too fragile for warm environments. Photosynthesis in plants, for instance, seems to use quantum coherence to transfer energy with near-perfect efficiency. Migratory birds may navigate using quantum entanglement in proteins in their eyes. Even the human sense of smell may rely on quantum tunneling. These discoveries suggest that biological systems can not only survive, but on quantum mechanics. If plants can use quantum strategies to harvest sunlight, why couldn't the brain, a far more complex and sensitive organ, do the same with consciousness? Penrose adds another layer. He argues that quantum gravity, an attempt to unify general relativity and quantum mechanics, could play a role in consciousness. His idea, objective reduction, posits that when quantum systems collapse, they do so not randomly but under the influence of gravitational effects. If correct, this would imply that consciousness is woven into the fabric of space-time itself. That's a staggering idea. It implies that consciousness isn't a bug in biology, it's a feature of the universe. Let's not forget the implications in physics. The black hole information paradox, raised by Stephen Hawking, questions whether information is lost when it falls into a black hole. But newer theories like the holographic principle and ADAS-CFT correspondence suggest that information is never truly destroyed. Could consciousness, if encoded in quantum information, also resist erasure? Let's dig even deeper. In Eastern philosophies like Hinduism and Buddhism, the soul, or Atman, is often described as eternal and non-local, meaning it exists outside of time and space. In quantum physics, we encounter non-locality all the time. Entangled particles separated by light years can affect each other instantly. Could the ancient concept of a boundless soul mirror what science is only now beginning to model mathematically? Even Carl Jung's ideas of a collective unconscious begin to resonate with quantum metaphors. Jung proposed that human minds are connected through archetypal memories. Quantum physics, especially in the context of entanglement and coherence, allows for the possibility of deeply interconnected systems. Could we be mentally entangled with one another in ways we can't yet measure? There's also the concept of quantum superposition, where something exists in multiple states until measured. Could consciousness exist in superposed states, potentially spreading across versions of the self, or even multiple timelines? Some researchers have speculated that quantum consciousness could explain phenomena like déjà vu, premonitions, or the Mandela effect, where large groups of people remember events differently than recorded history. Critics of Orch OR point out that there's no definitive evidence of quantum computation in microtubules, but new imaging technologies like cryo-electron microscopy are revealing unexpected complexities in cell structures. Quantum experiments in neuroscience are just beginning, and Hameroff and Penrose aren't alone anymore. Other researchers in Europe and Japan are exploring similar territory. Meanwhile, physicists like Michio Kaku and Sean Carroll admit that we still don't understand consciousness. And if quantum effects are at work in the brain, that would fundamentally shift the boundary between life and death, between thought and matter. So what does all this mean for you? It means that your consciousness might not be a byproduct of neurons, but a quantum pattern in space-time. It means your sense of self might not be an illusion, but a deeply real aspect of the cosmos. It means the ancient intuition that we are more than just flesh and bone may have a scientific future. This doesn't mean we throw out neuroscience, it means we expand it. Embrace the mystery, ask better questions. And maybe one day those questions will lead us to a unified theory of mind, a bridge between physics, biology, and the essence of being. Until then, keep wondering, keep looking inward and outward, because the soul of the universe might be staring back.